application of machine learning techniques for option pricing problems. Uh, I don't know if you are aware about machine learning tools or not, but I'll go through from the scratch one so that I'll just try to give you the idea that why we feel that machine learning algorithms are suitable for this option pricing problems, and how do we do it, what is the current existing literature on those. So let me share my screen and then we can start. If you feel wherever like any query, anything, you can ask. I hope all of you can see my screen. So let us quickly try to understand what we did in our last lectures. That apart from Professor Obick, whatever he has taught, discrete time model and continuous time models, the idea is that we have also discussed. Let us quickly recall that what we have discussed. We have discussed uh, Black-Scholes equation, right? Black-Scholes PD. Its derivation we have left, so that will be done today by Professor Obeck after this lecture. And then we understood that its solution and need for numerical methods. We have understood this also. Why do we need it? Third is we understood the finite difference method, right? And fourth, we understood the theoretical properties, right? What theoretical properties we have understood? Consistency, stability, convergence. I mean, the basic idea was that who guarantees that whatever you are going to do with finite difference method, that is correct, right? So this consistency, stability, and convergence, these three properties, they basically ensure that yes, whatever you are going to do, that is correct. Okay, so now then we did yesterday the MATLAB implementation, right? We discussed a code in detail, line by line. But I believe that when I'll share that code, or you can watch the recording. Recording will be available to you via some OneDrive or Google Drive link. So those who are interested, they can simply go through the recording and they can understand that how we should go for a code in MATLAB for solving a differential equation, specifically heat equation we have solved, right? And then these majorly we did these many topics, and today we are going to discuss the application of machine learning techniques in option pricing. So I have a very quick question that any one of you have studied this before? At least machine learning. Any one of you have studied machine learning? No. Okay. Anyone else? Any one of you have studied machine learning techniques? First, machine learning techniques, and then see machine learning in option pricing. You might not have studied, but did you study machine learning? Kishan. Okay. No. Anyone else who has studied machine learning at least? Okay, no issue. So we'll go from very scratch. So this lecture is about that we are going to study the application of machine learning. So I'll be going with very basic structure, that is artificial neural network, and we'll apply that to option pricing problems. So option pricing problem, we already know that what it is, that what is the fair value of that premium, right? We discussed many a times that we are paying premium, right? Whether it is a warranty, whether it is whatever, right? So what is the fair value of that? And we also discussed in last lectures that yes, computing that fair price is crucial, otherwise it may create issue, right? Computing that fair price is crucial because I mean, otherwise it will not be good for our economy. Okay, so this is what the idea is. Now let us quickly give a bit intuition to you, right? So prior to advent of this data driven approaches, like prior to advent of this machine learning approaches, what was there? People used numerical methods, people used least square regressions, etc., and they tried to predict the price. But suddenly in maybe past 2 decades or so, you see that there is a huge improvement in computing facility, right? We have computing supercomputers, right? We have large storage devices, right? I don't know if you remember that earlier we used to get a pen drive of 4 GB at very costly rate. Now in that rate you can get even at least 128 GB, right? So this storing the data, playing with data, I mean doing computation with the data, this has become easier in past 2 decades, and that is also one of the prominent reason why people are shifting from conventional numerical methods to data driven methods. So now coming to option pricing, the intuition is simple. First you should understand the intuition, that it is a problem where we have data. How to get that data, where it is the data, that I'll be discussing little late. But at least we know that stock market has that data, right? Stock market has that data. So these approaches, deep learning, machine learning approaches, these are data driven approaches. So what is that? That okay, you compute the option price not based on the PD or based on the any method like integral differential equation, etc. You predict the price based on the data you have, based on the data you have. Okay, so this is what the key idea is, that okay. And why do we feel that it is suitable for our problem? Because yes, there is lot of data. Why there is lot of data? Every day the trading is happening, right? I mean on all working days the trading is happening from past so many years. So if the asset price is something, rate is something, T is something, we know what is the option value. So that means we have the historical data for this, that yes, in past we can I mean we can have that data, that okay, for these parameters what was the option value. What does it mean? That oh, for testing, training our model, not for testing, training our model, we have the real market data. That just like uh, usually we give one example, right? That what is the training, that okay, there is a rod, right, heating rod. If you ask some kid, so he'll go to this, touch this rod, and maybe he'll touch once. Now he feels he doesn't know anything about heat or something, right? So he's a small kid and he'll touch this rod. Now what will happen? Now he is trained. If you ask him again, just go there, he'll not go. So this is kind of you have some mechanism and you are training your mechanism that oh, if these are the parameters, your price should be predicted this much. Okay, so that we are going to discuss in detail, but before that, so let us quickly define our intuition, that okay, before this much computing power, this much storage power, we used to rely on numerical methods. But now as we can store hundreds of GB data in single pen drive, right? We can do lots of computing within seconds. Why? Because we are having supercomputers, we are having very powerful computers at our in our approach, in our reach. So then it becomes I mean necessary just that you use real life data and you do computation with real life data and you predict the prices. We are more happy to see those prices because they are coming from the real one. So what is the key idea here? Let me first discuss that. What is the key idea? Because that is more important, right? So one key idea is what you do, you find the option from Black-Scholes model. That we know. We have some parameters. We will find the option price from Black-Scholes model. Agree? We have something, some parameters. We can find the option value from Black-Scholes model. This is easy. This is not that difficult. Why? Because we know Black-Scholes formula. We have studied it, and if we know the value of R sigma k t, we have to simply put that in that formula, and we can get the option. And what else you do? You compute the option value from ML. One of the approach may be ANN, right? We will discuss this artificial neural network. What you do, you simply compute the option price using ANN. I'm telling you what should be our first point, what we are going to do. And what will be our first point? Okay, compare it. Suppose our ANN is not even accurate as Black-Scholes, then no sense of talking, right? No sense of talking ML, right? Because even Black-Scholes is more accurate. So then why we need to talk? But what we realized in real life that yes, our machine learning models, our ANN, even simple, very basic structure ANN, that is also more accurate uh, than Black-Scholes model in many of the cases. So what is the gist? What is the crux of this lecture? That okay, for certain parameters we are given, we can compute easily the option price from Black-Scholes model. That's fine. We can compute, and we can easily compute. Not we can easily, but yes, we can compute the option price from machine learning models. We'll see, for example, ANN. Now, what is our first target? That we will compare this. If by comparison we get to, but now the question is, how will you compare, what the parameters you will take, how you will define the error, etc. So many challenges. It's not like very straightforward, but there are many challenges. But yes, so this is the key idea people are using. So those who are BTech students here, are those who are PhD students, are those who are faculty members, this may be taken up as a research problem, and it is very recent, very emerging research problem, right? This is a very emerging research problem, that how this deep learning approaches for option price prediction, right? So what is the key idea here? That by this GAN course, at least you are a bit aware of option price problem, right? I believe so. And for deep learning, I'll be discussing today, and Professor Obek will also discuss about deep learning approaches. And then how to collect the data, how will you do this I'm going to show you just now in this lecture only. And you get that data, and then you have to explore a bit more, and you can work you can start your research in this domain. This is a very new problem, emerging problem, and wonderful real life problem. Okay, so this is what we are going to do. This is the research problem involved in it. Those who are not research PhD students, like BTech students or MSc students, they can take this problem as a project problem, because this is also wonderful. Although lot more work is going to, it's happening in this domain. It's not like people are not working. People are working, right? So people are working in this domain, but yes, still one can explore, right? Still one can explore. Okay, so now moving forward in this direction. So what we discussed till now in last 15 minutes, that yes, there are research problems in this domain. What is the basic research problem? Okay, so what you can do, you can simply change this model. Suppose someone has done by ANN. So what you can do, you can change this model and then compare it with Black-Scholes, right? You can define a new deep learning approach, and then you can compare it whether your approach is better than Black-Scholes or not. And lots of people are doing it. So this is one research problem that can be taken up. Now moving forward to introduction, that why do we need these deep learning approaches? and what is okay. So traditional parametric models such as Black-Scholes model that have been widely used, however, they rely on rigid assumptions. Okay, can anyone quickly recall that what is the assumption in Black-Scholes model? Although it is written here, although it is written here, the idea is simple that it assumes constant volatility, right? But is it really true? Is it really true? Right. In real life, it is not true, right? The volatility is not constant. So what I'm trying to convey from here that yes, in many traditional models, even not in black source, even advanced models also, they assume certain things which are, and suppose Professor Obeck was discussing that borrowing and lending rate are same. There is no transaction cost. If you go in real life, this seems to be very hard that this is true in real life, right? It is very difficult. Okay, so the idea is that whatever the assumptions that have been taken to find out the option price theoretically, that those assumptions were very hard, right? So, I mean, very hard to believe, like, right? So, what happens that these, but why they have taken these assumptions? For simplification, right? For simplification. Otherwise, that theory could have been even more difficult. Right. So what happened? Then of course they may give wrong results. Whatever the option pricing option we are getting, I mean that might be more than the actual one. That might be lower than the actual. Agree. So what is the key idea? That to price option we have taken certain non-realistic assumptions while doing mathematics. If we don't do that, don't take those assumptions, then we are going to get nothing. So better people thought of that, okay, let us assume those assumptions and then find out the option price. We know that it is not 100% accurate, but yes, we know that at least it is giving us something which is near to the accurate, right? I hope everyone is convinced that why you can simply ask that if those are not realistic assumptions, why we are doing it. So if you don't do it, you will get nothing. So here it is like better to get something, right, than nothing. So by utilizing those assumptions, at least you are able to get something, right? So what machine learning does? What machine learning does? Learning complex non-linear patterns. There might not be linear pattern always, right? We all agree with it, right? Complex non-linear patterns directly from historical and real-time data. Yes, that's good. What it is all about, what it is saying, that suppose we have stock market data. So what machine learning does, it simply understands that data, right, that historical and data, right, and then it learns the relation, it learns the pattern between input and output variables, right, it understands the pattern between input and output variables. Agree? So now the idea is simple, that yes, whatever we are going to get here, that is real, that is on real data. Okay, and avoiding reliance on closed form solution, right, or rigid model assumptions. Means what? That it does not need any assumption, it does not need that you have closed form solution. What it needs? It needs a good machine learning algorithm and accurate data. What we need in machine learning approaches, good machine learning algorithm. So the people who are working in those direction, suppose they provide you a good machine learning algorithm and you have real time, I mean correct real data, so we expect that whatever the option price we will predict, that will be more accurate. This is what the whole idea is. Okay, so we understood that yes, what we are going to do in this lecture, that also we understood. Why it is important, that also we understood. and we understood that what are the research problems in this domain. So people, some students are maybe from PhD or from BTech, so they can take this problem as a project or their research. And what machine learning does, that I mean, what is the problem in the traditional methods? This is here, and what machine learning does, this is here. Okay, so let us quickly move that. I will not go in much detail, but yes, let us quickly move to some existing works. So this slide I have deliberately put simply that those who wish to work in this domain, right? Suppose you wish to work in this domain in near future. So these are very famous work, right? So you can maybe take a snapshot or you can watch the recording later on. So it started very early, right? In 1994, this is very highly cited work by Hutchison, right? So then people, I mean, it's not exhaustive list, right? There are so many, now people have written even review papers also. They have mentioned 250 papers that people have worked on it, right? But recently, in 2023, this is our paper with one of my MTech student. So here we have used this ANN and other methods for European call option pricing. So I'll be discussing a few things from this paper only. If you really want to understand other more basics, you can go to this paper by Professor A. Goswami from IISER Pune. So this is also a wonderful paper. You can read it. So those who wants to explore this domain, they can read these works, and I mean, this will provide you the better understanding and the real problem. See, it's not a cup of cake, please believe me, right? It's not that easy that, oh, you have data, you have machine learning, then everything will be good. No, this is also not the case. Why? I'll be discussing a few challenges, but let me tell you immediately one. Getting data is also not a very easy thing in option, right? Getting data, real-time data, that is also not a very easy thing. Okay, so here this simple architecture of ANN. So let us not go into it. So as I said that I'll be telling you artificial neural network. Some of you must have read this story that why neural network, right? So neural network is like artificial word is written that yes, it is right, artificial neural network. So some of you might have been told that it resembles to our neurons in the brain, right? So we have a lot more neurons in the brains, and they are also trained, right? Our brain trained them. So it is the same idea we are doing that uh, neural network also work on the same idea. Now, this slide says what I said, that you need two things. You need one machine learning algorithm and you need data. So what did I say? That machine learning algorithm I chose here, ANN, artificial neural network. Some of you might be aware. If you are not aware, it's okay. You can simply go to some book, and I mean, you can easily get that. It's not that difficult, right? But now the challenge is data. Data is really a challenge, right? So the question is how to get the data. That's the important thing. So we are taking here two assets technically, right? So the idea is that one is Nifty 50, one is Bank Nifty, right? So here I'll spend some time so that you are comfortable, right? And we took OTM data and ITM data. So let's not go into it. OTM data and ITM data, basically your asset price, right? Your asset price and strike price, right? So ITM, OTM, basically that your asset price S is less than K, right? So whatever for call option, please, we are doing it call option, right? We are doing it for call option. So we are doing everything for call option. This is first thing. So what is OTM option? That out of money basically. So please try to understand that if we have agreed to buy something at rupees 100 and its market value is 90, do you think we will exercise the option? No. Why? Because we'll go to market and we'll buy from there in the 90 rupees. Why I'll go to the because I have the right. I have the right. So I have the right, and I said that okay, we will buy your asset, right? We will buy your asset in rupees 100. This is K. K is what? Strike price. At what price we agreed to buy or sell. At what price we agreed to buy or sell. Right. Now S is 100. S is 90. And after suppose maybe 1 year, the asset price is 90 in the market. So what should I do? Should I exercise the option? No, of course not. We'll go to the market and buy from. So that's why it is called out of the money, right? Out of the money. In the money when S is greater than K, right? In the money that is, and at the money where we S is approximately equal to K, but in the money where S is greater than K, then of course I have. So here, what is the value of our option? Nothing. I mean, right? Because I'm not going to exercise this. So you can remember in this way that here this is called out of money, and if S is greater than K, then it is called in the money. Idea is simple. Let us make it even more simpler. Idea is simple. When asset price is, because at what price we agreed, that is very important, right? At what price we agreed, that is very, very important. So if our asset price is less than this, then we call it OTM option. And if it is greater than this, K, then we call it ITM option. Now let us come back to Nifty 50 and Bank Nifty. Anyone aware of Nifty 50 and Bank Nifty indexes? Anyone? Please let me know if anyone. So basically, this is what? This is 50 largest, right? 50 of performance of, maybe we can write like this, performance of 50 largest and most liquid stocks, right? Largest, right? Krishna is telling yes, very good, thank you. Good, Sukshan, very good. So if can anyone tell by unmuting themselves? I mean, it would be good if you tell, otherwise it's okay, right? So Nifty 50 is nothing but the performance of the index, right? The performance of 50 most liquid and largest stocks in listed on National Stock Exchange, right? So there is a National Stock Exchange, we all know, right? One is Bombay Stock Exchange, one is National Stock Exchange. We call it NSE. So on NSE, top 50 companies which are having the largest and most liquid stocks. So their performance is measured by Nifty 50. Anyone about Bank Nifty? Anyone about Bank Nifty? Krishna, Sukhjan, RS, do you? Anyone? So basically, it consists of the 12 large cap liquid banks, right? So it includes public sector and private sector both, right? So Bank Nifty is basically on NSE only, top 12 banks which are in market capital. Okay, you know a bit of Nifty 50. Okay, fine, no issue. So you can read, right? You can read from somewhere that what is Nifty 50. So Nifty 50 is basically the index of 50 most valued companies is listed on National Stock Exchange. Bank Nifty is maybe you call, it is dedicated to banks. That's why it is named it, right? NSE Bank also we say sometime. So Bank Nifty is that most valued 12 banks, maybe private sector or public sector. So 12 banks performance is measured by this bank Nifty. Okay, so we are taking the data of from NSE website. We are taking the data from NSE website of what? Nifty 50 index and bank. Okay, we are taking data from Nifty 50 and from NSE website, Bank Nifty of the data Nifty 50 and Bank Nifty. So now immediately question comes, how do we do that? Of course I'll tell you later that how what the size of the data, then when we filtered it, then we what we did, right? So that comes later, but immediately question comes that how the data will look like, how the data will look like. So let me show you how you can download the data. That is important, right? So just allow me a minute. Let me, yeah. So just a minute. I hope you can see the video, everyone. I hope you can see the video, everyone.
Yes, sir.
Yes, okay. So you see, you go to nseindia.com, then you go to market data, then you go to historical reports, then you go to contract wise price volume data. This video I'll be sharing with you all, right? No need to worry, no need to note it down or something. I just wanted to show you because it gives you at least some. So here you see lot many options were there. So we are taking index option, and here also you see bank Nifty is on the top and Nifty is also there. So suppose we want to take this Nifty 50. So we selected the year, then we selected the date, and then we selected option type, right? So what CEP? Call, European put, right? CEP, we took this from what time to what time we are going to download the data, and then we selected from this to this. Okay, so we just click on go, and you see here it is download CSV is there. See, you have this kind of data. It's not only this much, but yes, once you can download that this here on the download CSV. You simply click on download CSV and you'll get the CSV file. So we got this, right? I'll show you the data, don't worry, right? I'll show you the Excel file also. So this is what the idea. So I hope everyone had this idea that how to download the data at least, right? Now let me show you the data file, data set also. So let me just show you the data set. Okay, so just 1 minute. Uh, that yeah, it's so yeah. Let me share the screen. Yeah, you see here we get this kind of all of you can see this, right? I hope all of you can see this, right? So the idea is simple that when we download the data, we get this kind of data that 1st January 2014. The expiry is 30th January. Strike price is this: open, high, low, close. See, we cannot go in, I mean, in much detail due to the time limitation, but I'm just trying to give, because see, if you are doing machine learning approach, at least you should have like time to maturity. TTM is time to maturity, right? So how many days? 29 days. Okay. So here underlying value is this, right? So the idea is you have this kind of data. Of course, we have to do lots and lots of things with the data, right? So now, what we understood from these two videos and file, that how, I mean, how the data looks like, so open, high, low, close, and then how to download the data. Please understand that I'll be sharing these all the files with you, no need to worry. And these files you can, as I said, that this is our work. So in this paper also there is a GitHub link. From there you can download this data, right? So this data is publicly available. It is what we have downloaded. I mean, it's like it's not every data is publicly available. Please remember that once you go to NSE website, you cannot download the data for more than 3 months. So you have to download three months, and then the question is here. You see, you get the raw data. There are so many issues with. So I don't know whether you are familiar with the word data pre-processing or not, but then you have to filter it properly, and then you take training data, right? And then you take testing, right? So then what the idea is simple, that you get raw data, you filtered it. So you see, from raw was like too much, right? And then you filtered, and then you got training, and then testing. So this is how you prepared your data. But question is not this, right? Question is like, if you do if you compute your price, how will you ensure that this is accurate, right? That is the main question. That how will you ensure? That means we have to define some error metric, right? Some parameter which ensures that yes, right? Right. So this is what we are going to discuss. So the idea is,
Your screen is not visible, sir.
okay, just. Yeah, actually, I shared that. Yeah, now I think it's visible. Okay, so the idea
Yes,
is
yes, yes.
that, yeah, thank you. So the idea is simple, that okay, suppose we predicted some price. So I'll be discussing here a few things before going further. So what we did here, what we did, I mean, as I said that I'll be presenting what I have done in this work. So what we did is, see, option price will be one value, right? Option price will be one value, a value, right? But what we did here, we did the predicted the price segment. What is that? That suppose this is the range, right? So option price will be suppose this. But instead of this, what we did in this, in our work, we gave that okay, your option will lie here. I mean, we predicted a segment, right? We call it bin, right? We call it bin. So we predicted a segment. That's why here the word is coming bin, right? So we predicted the segment that okay, this is first bin, this is second bin, this is third bin, this is fourth bin, this is fifth bin, this is sixth bin, etc. So we said that okay, your option price will come in this bin. The reason is simple, although we have explained in detail in our work that why we did so, but let me give you quickly that single price prediction may not be very accurate, right? May not be very, because uh, in real life there can be more than one fair values of option, right? So if we give only one, doesn't seems to be very realistic. So the idea is that what we did, you can simply understand that we predicted a bin for this option value. Now we are coming to this evaluation metric. What is evaluation metric? We all know, right? Evaluation metric, by metrics means parameters, right? So evaluation metric, that whatever we have done, how, just like previously, right? How does it guarantee that what we are doing is correct or not? Okay. Okay, so the idea is simple, that yes, we used ANN, we took this data, we filtered, we trained. We are not going into coding, etc. Those who are interested, they can explore. But suppose you predicted something. You predicted a bin, that okay, there are some parameters S, K, R, sigma, T. Now you said that okay, uh, your option price is from this to this. Now the question is, so try to understand. Let me change the color. I'll make it a bit more clear here. That your black soul said that your option price would be in this, and your machine learning said that your option price would be in this. So there is an error. I mean, there is a difference. Agree? So based on this difference, sometimes this difference will be very less, or sometimes maybe black holes also says that your option price would be here. So sometimes your errors would be very less, sometimes error can be more. So based on this error, can you define one number, right? So these are numbers, that by looking at NEM, normalized error metric, and rho is inaccuracy metric. There are two metrics. These were defined in the paper by Anindya Goswami, which I said, right? Anindya Goswami, this paper. As I said, that if someone is interested, he can go to this work, this second last work, yeah, published in 2021. So they defined these two metrics, that okay, based on these two metric, we can realize that yes, how better our prediction is, right? What is the idea? That how better our prediction is. So let us try to understand this, what it is. NEM, right? That AK is the exact bin number. Exact bin number, how do you get that? See, from real data, right? You have the option value. You have the option value. So what you know, if you have the option value for training data, so you know in which bin it is lying, in which bin it is lying, and PK is the predicted one, and you suppose exact one is this and predicted one is this. So this is AK, and AK is what? Bin number. Please try to understand. So we have numbered all these bins, 1, 2, 3, 4, 5, 6, 7. So basically our exact bin number is 3, predicted bin number is 4. Okay, so what is, and M is what? M is total number of contracts in the data set. Basically, how many rows in our data set? That, that number of contracts, that means that number of rows in our data set. So we have seen like roughly how many this filter data, 14,000 rows. So what we realize here, M we understood how many rows in our data set, AK we understood, PK we understood, D is bin width. So that is also important. Okay, so these two metric we have defined, not we have defined, we have, as I said, I clearly mentioned that we have borrowed from some paper, and they have mentioned these two metric. And now please read these two. This is clearly saying what it does. So NEM actually measuring, what it is measuring? It is measuring how far the predicted bin is from actual bin. Means actual price is here and you predicted something here. So how far it is? And we are taking kind of weighted average kind of thing, right? Because we are multiplying by D by M. So I don't know whether you are comfortable with weighted average, etc. or not. So we are taking here weighted because we are dividing by M. So M is the total number. So something, if we divide by total number, we take that average, right? And then just like we find the mean. So what we do? We add it up all and then we divide by the total. So here it is this, we are doing the same. Don't you think so? We are adding all these differences. Agree? It is the sum sign. We are adding all these differences and then we are dividing by m. So it is not simply average, it is we are multiplying by d also, it is weighted average. Okay, now what is our inaccuracy metric is doing? Rho. The rho metric, basically we call it inaccuracy metric, measures the probability that the model estimates falls outside a window of 5 successive wins. From where this comes 5? With the predicted bin positioned at the center. So let us try to understand. AK minus PK is greater than 2. That means what? Suppose this is the predicted bin. Right? This is the predicted bin. So this is 1, this is 1, this is 1, this is 1. So now AK, this is predicted 1, PK, right? Predicted 1 positioned at the center. Let me change the color. And yes, right. Now your AK is, if AK minus PK will be greater than 2 if AK is here? No, it will be equal to 2. No? If AK is here, then also okay. This condition is not satisfied. Agree? This condition is here, AK is here, this condition is not satisfied. But if AK is here or here, then this condition is satisfied. So that means what? That this AK, right, is following 5 successive bins, right? This becomes 5. Okay? NEM is normalized error metric. I mean, it is just error. So all of you know mean absolute error, right? Mean squared error. Mean squared error, maybe most of you have heard, right? Let me write it. Okay, just 1 minute. Okay, Jai Kishanji, mean squared error, right? What we do? We take the square of error and then we take the mean of it. Mean squared error, most of you have heard, right? You have actual, you have predicted, you subtract it, and then you take a square. You take the square of error and then you take its mean. So if you take d equals to 1, technically it becomes mean squared, mean absolute error, not mean squared error, mean absolute error. Right, because what you did, you took difference, that is error, you took absolute value, that's fine, and then you took, you divided by the whole number, m, that means it is becoming mean. So am I clear, Jackishan, that so there are so many types of errors defined in machine learning concept, mean absolute error, mean squared errors, as I said. So NEM is also one quantity which measures the error. That's it. It is written here. NEM is what? NEM is a number. You'll get a number. You see here. I'll show you, right? I'll show you this NEM, etc. So NEM is a number, and using that number, you can visualize that how far your predicted win is from the actual win. So basically, it is a error, right? Is an error that okay, if some NEM is this value, that means it is not that far. If any, just like error, how do we convince ourselves with error? So if error is 10 to the power minus 4, we believe that oh, our prediction is perfect. If error is 10 to the power minus 2, then okay, our prediction is okay. But if error is 1, oh, then it is not okay. So it's a number, right? Error is a number which tells us that okay, uh, which tells us to decide whether we are predicting the accurately or we are not predicting accurately. Right. So NEM is that, and rho is also that. So 5 successive wins, you can simply see here that if AK minus PK is greater than 2, that means what? It is lying out of those to this side to this side, because absolute value is there. Okay. So the model's estimate falls outside of a window of 5 successive wins. Okay. So if AK minus PK is greater than 2, that means what? If either AK is lying here or AK is lying here, it is not lying in this window. I hope this is clear, right? AK is not lying in this window. If AK is lying in this window, then this will not satisfy. Okay. If AK minus PK is greater than 2, that means it is not lying in the window of 5 successive wins. It is lying somewhere outside. So what basically rho is telling you? Rho is telling you, and you see here, so and you are dividing by m, so basically it is favorable upon total kind of thing. and favorable upon total, it gives us the probability, right? That's why it is written here, the row metric measures the probability that the model estimate falls outside the window of 5 success. So those who are more interested, they can go to this either our paper or paper by Professor Goswami, and you can I mean, we have written lots and lots of things about these two metrics. We have explained in detail. I tried to give you here also. So normalized error metric is basically a number which is telling us that how far our predicted bin is from the actual bin. Bin is basically that box, you can understand. Okay. Rho is the metric that what is the probability that model estimate falls out of this window. This is window, right? And window of 5 bins. Window of 5 bins. So what is the probability that it doesn't? So just like you understand that your option price is 100. So it is not even 101, it is not even 102, it is beyond 102. Or it is not even 99, it is not even 98, it is beyond 98. So it is not lying in that window of 5. Lemon language, what you can understand that, okay, these two are numbers which will help us to decide whether we have done the things correctly or we have not done the things correctly. Okay. Now, most of you might have heard that whenever we are going for machine learning models, we need to define the features, what features we should take to predict. So how will you predict basically, right? And the question comes, how will you predict the option price? Right. So here we have discussed 3 strategies, right? Here we have discussed 3 strategies. Uh, I can explain the first one, that we are taking here 22 features. What 22 features? Log return of previous 20 days returns, close price. So log return, so basically your return and you take the log of it. So log return, so 20 days log return is there from the data. Please try to understand, there is data in your Excel, you figured out log return. So for that, maybe what you'll do basically, LR means log return, right? You will first figure out return. So return is basically previous day price divided by the current day price, and then you figure out log return. So log return, actually there is definition simply you can use. So just a minute, right? So you can use log return for right. So idea is you can find log return of previous 20 days. So how many values you'll get? You'll get 19 values, because log return is what? Log of that day price upon previous day price. So if you divide, you have, suppose you have 5 numbers, right? 1, 2, 3, 4, 5. So how many values you'll get? This by this 1, this by this 2, this by this 3, this by this 4. So understood? You have 5 values and we got 4 log returns. So for 20 days, you'll get 19 log returns. I hope it's clear, right? So here you'll get 19 log returns and 3 are this. So 19 plus 3, 22 features you are using. Again, let me explain that you have X data in your Excel file. Okay. Now you have to take what feature I should use to predict the option price. Okay. What feature I should use to predict the option price. So what you are doing, you are simply taking the log return of 20 days, right? 20 days means 20 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I said, right? And once you find the log return, so for log return, you need 2 days data like this. This and this will be 1, this and this will be 2, this and this will be 3. So here I have explained to you clearly that if you have 5 days, like 1, 2, 3, 4, 5. So how many log returns you'll get? Let me change the color and tell you, right? So this is using this and this, you'll get 1. Using this and this, you'll get 2. This and this, you'll see 3. This and this, you'll get 4. Right? Agree? So agree. So here you have another approach. So it's not like these only features you can take. No. What we discussed, we took different features and then we try to understand that, okay, if you take this feature, what will happen? If you take this feature, what will happen? So those are working in machine learning, they might be aware of these things, right? So in another one, we took covariance log return of open high low close. OHLC means open high low close, and we took mean log return of open like high low close, right? Agree. So the idea is here we get 17 values, right? So as a feature, so mean return basically mean of open, mean of uh, right, right. So the idea is simple that what is descriptor group B? So please try to understand mean log return of OHLC. So one is coming from open, one is coming from high, one is coming from low, one is coming from C. So these are four and three are this. This is common in everyone. These three, right? These three are common. And if we take covariance matrix 4 cross 4, so there are 16 entries, but covariance matrix is symmetric, so there will be 10 different entries. So 10 are those. So this becomes 70. Okay, so you might feel a bit not comfortable. I understand, but I'm just trying to tell you that it is not that difficult also, right? Please do not be confused that why we are taking 22, why we are taking 17, why we are taking 19. Try to understand that, yes, there are many ways you can utilize those features and you can do the prediction. This is what I wanted to convey. What I wanted to convey, that there are not only single way that, okay, this is the feature you have to take and you have to predict the price. No, right? So this is what I wanted to convey, that here we took in first approach, we took 22 features. How did we get 22 features? 19 from these 20 days. And why 20 days? So in 1 month, roughly 20 days, the trading happens, right? Because many holidays, etc. Right? So the idea is simple, that we took, so basically 1 month, right? Basically we took 1 month data, and then these three features are important: time to maturity, interest rate, and moneyness. Please be clear, this interest rate is very crucial, right? This interest rate is very crucial, right? So what we took the RBI, I mean, past 3 months, this bond yield basically, right? So that interest rate data also I have. Let me show you just a minute. Yeah, yeah. Let me show you. So how will you choose this? Just a minute, okay? Yeah. Uh, yes. Yeah. So how will you choose this R, right? So here we have this 3 month bond yield historical, right? And from there we chose this R, interest rate, which is called interest rate. So please be clear that this interest rate feature, from where you are getting it, actually, I'm trying to explain. Moneyness you can get from the data, time to maturity, it is written there, 29 days, right? But how will you get interest rate? So for interest rate, you have to do a bit of more efforts, and you have to get that data from maybe from RBI website or from some other authenticate website, and that you can choose as a interest rate. Okay, so I mean, what my purpose is to telling in all this, that yes, data, I mean, you have Excel file, but preparing features, right, making features, it is also not a easy thing. You have to be very careful in preparing features, and once the feature is done, right, feature set you have prepared, then fine, then now you are ready with your feature set, right? uh, Many these platforms, Visual Studio or Google Colab, simply you can write a code in Python, you can run it in Google Colab. I don't know how many of you are, I mean, comfortable with Google Colab. Anyone heard of Colab? No. So the idea is simple. Okay, let me show you at least once. Otherwise, so how do you, yes, you have, okay, Aditya. So thanks, Aditya is knowing. Anyone else? So I have shared my whole screen, right? So the idea is simple, that you can simply open Google Chrome, and you can, in Chrome, you can simply type collab, right? Use to run Python. Yes, good, very good. And then go to welcome to Google Colab, and here you can open some notebook, or you can simply create a notebook, right? And here you can simply run it. So what you have to do, you have the data, you have this platform, right? Here, from here, you can simply I am using this for R, right? You have to change, I mean, you must be using it for Python. So you can simply run it. So what we have in our hand now, what we have data, right? We have platform, and we have machine learning tool, that is ANN. Simple tool. I'm not saying that you take a very complicated one. No, no need, right? So everything we have, and of course we have to do the coding, etc. So for that, some of you might be comfortable, some of you might not be comfortable. So here we took three approaches actually. So approach A, only reason is just to see the applicability of machine learning approaches in various ways, right? So in one, what we did, that we took the single assets, right, Nifty 50 and Bank Nifty. In approach B, we took this Nifty 50 and Bank Nifty data set, and findings are presented, aggregated basically data set. And approach C, actually, we trained the data on this 14 to 18, but tested on 19 and 20. So why 19 and 20? Because in 20, COVID came. So there are sharp jumps in the market, right? So when we realize that, okay, if we train on non very smooth way, right? I mean, 14 to 18, there was nothing so bad, right? So we trained the data here, but tested on this. So it may have some issues. We all agree, right? We all agree with it. So these three things we try to do in training, right? So training and testing, some of you might be aware, and then we got this, right? So what it is, that for OTM options, if you see, using NN only, our NEM is less than Black-Scholes, and rho is also less than Black-Scholes, right? NEM and rho both are less than Black-Scholes. But for ITM, it is not. So ITM, this ANN is not performing well, but for OTM option, this ANN is performing well. Okay, and the same way we did for this is what for this is for approach A. That means we are taking individual Nifty 50 separate, and Bank Nifty separate, right? Then we took this like aggregated data strategy. We did this, and for quick shift, like we tested for 1920. So here also it is not bad, right? For OTM data, it's okay, right? It is 0.190, it is 0.04. Still, our results are better using NN for OTM data. Okay, good enough. So let us quickly recap, and let us try to figure out some research problem out of this. We did what, so what we understood from here, that what we need actually, if you want to explore in this dimension, let us quickly understand the need, right? Okay, let me give you some references before that. So these are a few good references which you can look at if you wish to explore in this domain. As I said, that this paper by Professor Goswami and this paper by Hutchison, this is one of the oldest paper in this dimension, right? So wonderful work, and by this Meliaris and Hutchison, right? And this is our work. You can, I mean, if anyone is interested, I can send this paper, and you can read about whatever we have presented here, so that you can read in from this paper. And most of the results are from this paper only. You can read. So now let us quickly summarize. Actually, that is more important, right? What is that? If you want to explore in this dimension, so first thing is we have to be comfortable with machine learning algorithms. Right? You have to be comfortable with some machine learning algorithm. So you may be knowing ANN, LSTM, GRU, right? There are various algorithms. So you need to understand one of those algorithms. We need to understand whether it can be applied to our option pricing problem or not. That is first. Second challenge comes that data. This is really a challenge. Right. So let me tell you that if we take any platform which provides us the data, right? There are many platforms which provides us the data, and but they are very costly. It's not that easy one, right? They are very costly. So if we download from an SCBSE, we have lots of very large data. Then we have to filter. What it means by filtering? That there may be some values zero or none. There is no value in that column or row. So you have to filter that data appropriately. And so what it is, the data pre-processing, right? Data filtering the data, etc. This is one challenge. Another is feature selection, right? What is the challenge? Feature selection. You saw here, right? You saw here why we are choosing these features, right? There must be reason. If you have, I mean, heard the lectures of Professor Obed carefully, he has many times emphasized that what are the benefits of log return, right? So keeping in mind that benefits of log return, actually we are taking log return as a feature, right? This is one thing. You see, everywhere it is log return. Log return is very important. Okay, so we have kept the log return of previous 20 days. This is one. I mean, these are 19 features, and one, two, three. These are very crucial things. All three parameters are very crucial. Moneyness basically involves S and K, right? So asset price is also there, strike price is also there, time to maturity is also there. So basically, S, K, R, T, all four are there. And volatility we don't know. So volatility basically we are trying to capture from here. Right? And if you recall Black-Scholes formula depends on SKR sigma T. Yes, this is it. So SKRT we are getting from here and sigma we are getting from here. So what I'm trying to convey? I'm trying to convey that whatever the parameters Black-Scholes formula it needs, we are giving the same feature. We are collecting the same feature from data and giving it to the machine learning model. Right. Okay. So the idea is that we are collecting the same feature from data. It's not from assuming something that this case this. No, we have not assumed anything. Even R also we have taken from real life, right? Real what RBI is fixing, what the bond yield is there, right? So try to map those things, right? One, that in Black-Scholes we put SKR sigma T and we get the option value. This is one thing, right? Another thing is we are from data we are finding SKR sigma T and we are giving it to machine learning model. So technically features are almost same in both the scenarios. Okay, we are giving the same data and not only one, right? We took, okay, fine, we take some other feature, now we take some other feature, and then we take these features and for all three feature set. Descriptor group means feature set, right? First feature set, what we are getting the option price. Second feature set, what we are getting the option price. Third feature set, what we are getting the option price. So this lecture I kept deliberately to explore because nowadays many of you must be, I mean, hearing about that everywhere. This AI, ML, deep learning, etc. Many applications of artificial intelligence, machine learning, etc. So yes, this domain also has wonderful application of machine learning approaches. You can take as a project work, you can take as a PhD, you can take as a like simple BTP thesis, etc. if you are a BTech student. So this So once we prepare the data, then importantly, how will you, how will you ensure that whatever you are doing, it's correct? That is correctness. So how you are ensuring that whatever you are doing is correct? You have defined, we have obtained two parameters, two numbers, and those numbers are going to tell me that whatever we are going, it is correct. What are those numbers? One is called normalized error metric, and one is called inaccuracy metric, right? NEM and inaccuracy metric. So these two parameters ensures that, okay, whatever we are doing, this is, and from where we will compute it, we will predict something and there was something accurate, exact, just like in numerical methods we found the error, right? So here something we predicted, something was exact. We from those two values we computed NEM also, we computed inaccuracy metric also. What is NEM and inaccuracy metric in detail? That you can read from here, and we try to discuss also that we are defining bins, which there will be one predicted bin, there will be one actual bin. Based on these two, predicted bin number and actual bin number, we are computing this normalized error metric and inaccuracy metric. Inaccuracy metric is nothing but it is the probability. That what is the probability that you are predicting, whatever you are predicting, that is not in this window, that is outside this window. So why we are taking two? That we feel that, okay, if you are predicting your value in this window, we believe that you are accurate enough. But if you are even outside this window, then you are inaccurate. Then you are very inaccurate. Right? Agree? So your predicted value, your actual value is suppose here, and your predicted value is out of this window. So then it doesn't make sense. That means you are making huge error. Right. So based on those concepts, this rho and NEMs are defined, and then you conclude, then you compare your results with Black-Scholes model. And we realize that yes, under certain cases, so right, so first is ML algorithm, then you took not data, means basically financial data, right? Financial market data. So what we realized? We have certain machine learning algorithms, we have financial market data, we did filtering, pre-processing, etc. We selected the features carefully. Then we applied this data, we gave this data to machine learning algorithm. We got something. How will you ensure that whatever you got is correct? That's for that we used this normalized error metric and inaccuracy metric. From that, we compared our result with Black-Scholes model. But we realize that yes, in certain cases our results are better, in certain cases it might be worse also, so we will not go in that case. We'll go where our results are better. We'll only talk about when our results are better. Why to go when the results are not better, right? Simple. So this is all about application of machine learning for option pricing problems. Thank you so much for your kind attention. This was my last lecture. Now Professor Obek will take two lectures. He will also be discussing about machine learning algorithms, right? In one of his lectures. I request everyone to please attend that lecture also. And one more important information to all the participants, that your feedback is very important, right? For us, for Gyan also, right? So we'll be sharing a feedback link to all of you after the lecture, all the lectures ends, right? After all the lectures ends, and you need to just, it will be a Microsoft form. So all of you are comfortable with that form, I believe. And you need to simply fill that form and provide your feedback. Any queries from anyone? Otherwise, we can wind up this session. And please note that next session will start at 11:30, after half an hour. Any queries from anyone? Yeah, so thank you so much for your kind attention, everyone. We are winding up this session now, and we'll meet at 11:30.